Hi guys, welcome to Insight Tuesdays. In this series, we will be navigating the world of observability, which means we will be learning about observability in the security environment. So, what's the agenda for today? First of all, we'll learn about what is observability, how, and why is of observability. Then we will have a comparison in monitoring versus observability because it is a common misconception that these are synonymous or they refer to the same thing, but it's not. Then we'll talk about the first pillar of observability, that is logging. And then we will explore a very versatile tool, that's Splunk, for logging. And so let's get started. So, observability in the context of software development refers to the ability to understand, measure, and debug a system's internal state and behavior from its external outputs. It involves gathering, analyzing data from various components of a software application to gain insights into how the system is performing, identify issues, and troubleshoot problems effectively. So, in a layman's term, or if we talk about it simply, it means it is a doctor which sees your symptoms, your outside symptoms, and then um, incept what would be the root cause or what are you suffering from. So similarly, observability is crucial for maintaining and improving the reliability, performance, and overall health of a software system. So if you see this diagram, it is a comparison between an industrial system, like mainly of a plane, and in a software system. So if you see in a industrial system, it refers to the velocity, direction, and quality that an airplane is providing or its component is providing. And similarly, on the other side, you can see in a software system how the logging and metric functions are getting recorded. So if you talk about a shopping cart, logging would mean adding to the cart, and metrics would mean checkout, and then the whole would be given into a bill that would be a trace. So these three are the pillars of observability. We'll talk about it in the next slide. So these three are the pillars of observability. Not only this, we also have extended versions where we talk about visualization and what do you say, analysis as well. But these three mainly componentize the observability into a software system. So first of all, we have logs and the major agenda of today. So logs, as it suggests, as you know, even if you talk about error logs or anything, these are detailed records of events or activities that occur in a system. And what are the significance? The significance is simply that it helps in tracking the flow of execution, of course. And when you have to identify an error, you don't have to go through a whole code. You can just see its highlight, and then you can understand how different components of a system interact as well. So you can have an example as server logs, error logs, or application logs. Then the second pillar is metrics, which is a quantitative measure that provide a high level view of the system's health and performance. So when you have the logs, these got analyzed and then they are formed into a matrix which you can visually see. So these metrics offer insights into the overall performance, resource utilization, and behavior of the system. If you have ever noticed, if you have ever seen on your task manager, it shows you the CPU usage, memory usage, response time, throughput, things like these, even if you can see in your smartphones as well. Then the third one, of course, are traces. So traces are records of the flow of transaction or a request as it traverses through the components or services in a system. What are they useful for? They're useful for understanding the end-to-end journey of a request, identifying bottlenecks, and analyzing the performance of a distributed system. So you might see that you might think that logs or traces, what is the difference? Basically, logs record everything, and then you can trace it back through traces, like it highlights whatever is important, and you can see the whole execution. So, a significance of observability, of course, as we talked about the pillars, you might understand what is the significance of observability in a software system. Observability in software development is crucial for maintaining and enhancing complex system. In a small system, it might seem easy to track down the errors and solve it time to time. But in a complex system, which comprises of many microservices and many third-party applications, it is very hard. So you have to create this ecosystem to trace back the bottlenecks or the vulnerabilities that can be caused if there are any loopholes. The significance of observability lies in its ability to detect and diagnose issues promptly through detailed logs, metrics, traces, facilitating root cause analysis, and faster resolution. It might seem a little exhausting, but there are tools out there which help you for every and each step, so you don't have to worry about it, and you can directly get the resources and the results. So it also enables proactive issue prevention through anomaly detection and supports cross-functional collaboration by fostering common understanding among development and operation teams. So let's talk about what's the difference between monitoring and observability. They often come out as synonymous, but they're not. If you read this quote, you'll understand what's different. It's the same difference as in looking and understanding. So observability gives you insights, and looking just gives you a visualization. So these are the major differences between monitoring and observability. Monitoring majorly focuses on a metric-driven system. It is centered around and predefined metrics and key performance indicators that are crucial for the normal functioning of the system. It also have thresholds for these metrics, and mainly monitoring is pretty static and observability is dynamic. Then there's the passive nature of monitoring, that is the difference between static and dynamic natures of both the aspects. So it gives you automated alerts. Monitoring systems often operate passively, automatically generating alerts when predefined thresholds are crossed, and it gives emphasis on reacting on the known issues. Also, it gives you only limited context. It gives you snapshots of specific metrics and may lack the depth that is needed. But observability, on the same hand, is very dynamic. It gives you a holistic understanding, like if it gives you diverse data sources. It takes up logs, traces, and events, providing a more comprehensive view of the system. Secondly, it has a dynamic exploration. It analyzes different aspects of the system to gain a better view, or what you say, a wider view. So your complex system don't have any loopholes when it goes on the production side. Also, it has proactive exploration, which is active inquiry, and it encourages developers to ask ad hoc questions and explore data in real time. So you can actually see when you have the dashboard or when you have the dynamic data in front of you, you can actually see the bottlenecks waving in front of you, and you can point it out and you can ask the corresponding team about it. So it gives you a better, context rich or a better correlation of data with tools that are facilitated. So if you see the differences, they are basically the dynamic side. Monitoring pillars are basically, the static side, and on observability is on the dynamic side. So it is like the extended version of it, and it gives you better results. So you might understand it as the shell, or the dynamic shell of monitoring. So it is better to adapt observability instead of monitoring. So 70% of organizations have implemented observability, and among those, 83%, among those 70%, 83% have saved time and money, because when your system or your applications in use is compromised, it causes the harm to your brand, it might cause harm to your consumers. So some companies always juggle between tools and data sources, but different industries are at different stages of adaptation, and that's all right. There are different tools, and they try to use different tools for different aspects of observability, different for logging, different for metrics, different for tracing, but that's all right. But it is always said that of a centralized approach is better, because you get all the data at once. And on the other hand, when you have a decentralized approach, you get a wider view. So both have their pros and cons. It's up to you and your finances how you want to have that ecosystem. You can have it centralized or decentralized. Most of the companies or organizations or individuals go with the centralized approach, because it's easier to navigate in that way for their employees or their teammates. Now let's talk about the first pillar of observability, that is logging. um, so why do we need logging? Till now we're like almost clear about it, that these are the events that have been that it captures, and it also gives you the track record of the whole application, or anything that has happened in the application with a timestamp, so you can go back to it and trace it. Why bother? Of course, because it is a valuable source of information for troubleshooting, debugging, monitoring, and ensuring. Imagine a scenario where you code and it doesn't run, and you don't have the error logs. It would be impossible for you to create another code that works if you don't know what the error is. So that is the significance of error logs, and this is the simplest way you can understand. So these are some of the aspects of logging. Troubleshooting, of course. If we take the example of error logs, we always seek those when there's a problem in our code, if it's not running or not giving our desired output. So first, the major aspect is troubleshooting. Second is application behavior. So, log entries help understand the flow of execution. As if you have ever noticed in your compiler or debugger, if you ever see it, you will see that it gives you the whole flow, that what's going right now and what will be next, and in queue. So you can see the whole execution in those logs. Second is performance monitoring. Logs reflect applications responsiveness, resource utilization, and overall efficiency. It shows you how much time it is taking and everything. And also security insights. That is the major role of observability ecosystem. That is give you security logs, which provide you information. If there are any bottlenecks, you can fix those. Now, these are some of the reminders that you have to keep in mind. You can't skip these. You might want to know it when you are implementing logging into your systems. Number one is do not include sensitive data, as in passwords or personal information of individuals, because it can create a security risk. Logs are publicly available, and they can be traced back. So it's better that you do not include such information. And if you have to in any scenario, please encrypt those. Second is you have to understand and use different log levels, and also you have to educate your fellow developers or your subordinates about it, your organization about it. So these are some of the levels that are debug, info, warn, error, and fatal. So this is also how you can ramify logs into different different columns. That yes, these are also like the vulnerabilities, like priorities. So, and third is considering the performance impact of logging. So it is often that logs can be exhaustive. When you record logs, it might record everything and it might take a lot of volume. So you have to make sure that you have enough volume and your logs are not over recording. So it is better that you create such queries which record only the important aspects of your application. And of course, most importantly, document the log levels, formats, and any conventions used in your logging practices. So the other people are able to understand this. Now, we'll talk about a very powerful, versatile tool that is Splunk. And we'll also go through the demo. But let's talk a little about Splunk, why we have chose it, and its major aspects. So it is a widely used platform for log management, analysis, and monitoring. Today we'll be surfing through it, and we'll also see how logs are managed into it and how you can also index it. So the most important, or what you say, the most convenient thing that Splunk has, that it can ingest and index data from variety of sources, including logs, metrics, and events. And other than that, it has its own search processing language that allows user to custom search and analyze. So it's like more, it's more like a relational database query, but it is much convenient. You can inject it with a JSON query and it will give you a custom results. Other than that, it already has the major general results and general indexes as well. So it helps organizations gain insight from machine generated data, including logs, by providing powerful search, visualization, and analytics capability. So it reduces your dependent database, what do you say? What do you database dependency? It also has cloud, so you can also connect it with that. Now let's go on to the demo. So this is the official page of Splunk. You can download it from here. I am using it today on Windows, and I have already downloaded it because it takes around 15 minutes. So it's a very easy process. You just have to fill the form, you have to verify your email, and then you will be redirected to the download page. So you can download it for Windows, for Linux, or Mac. It's up to you. So this is the search and reporting page. Now, if you have to create new logs, I already have some, but let's create a new one. We have to go to data and data inputs. So today we what we'll do, we'll take local data that is from Windows. So everyone can try this out. You don't have to depend on an application data, but if you want, you can also have the Splunk Observability Cloud. That is, if you want to connect it with your cloud or enterprise stuff, you can do that too. So in this model, you can create local event logs, remote event logs. But today I'll be taking the CBS logs from my Windows and we'll surf through it. This Windows and let's see. Yes. So the this is the default setting for continuously monitor, or you can do the index ones. We'll go with the default settings because we have to do it continuously. And next, okay, okay. So it already exists because I've created it before. I need to delete that. But with the default settings, you can go further and you can also add an index. So right now, I have, yeah, okay. Hmm. Yes. So if I go to the indexes, I have a custom one that is AC. Yes, it's showing this. Yes. So this is the CBS data log. As you can see, it is from a local host. And these are all the logs from, right, it's all right. It's from 740. Okay. So it's around, okay. It hasn't done something from like last 40 minutes, but it's fine. Yes. So you can see everything here. And the index is AC1 because when I created these logs, I created an index to identify it through a lot of data. So my Windows logs have thousands of logs, right? Uh, they have under the log section, there are many folders and there are many logs that are working correspondingly, and there are thousands of entries. So when I created this index, just like you create an index in SQL, I can easily identify that I want the CBS data. So similarly, you can also create an index which will point out to your particular um, log, or what do you say, log section. So if you have an application or you have a lot of application that might have thousands of data or millions of entries, so you can find it through an index. Now these are some of the general indexes as well, like for example audit one. Now see the difference. Okay. Yes. Yes. So these audit trails are not from the CBS logs. These are different, and it might also, you know, contain some of the CBS logs as well. But then I have to create a SQL query from here somewhere. Yes, which I can inject through JSON or HTML file, and it will create those logs like that. So this is a simple query. If you see at the back end, it would seem like a simple query that we run on an SQL database. But this eradicates the need to go through the complex process because it's running on SQL. So this Splunk processing language. So it is pretty convenient. You can see all the logs, you can index them, and not only index them, there are many fields that you can add. You can add host, source type. These are the interesting fields which you can add. If I go back to AST1, these might differ. Yes. These fields are different now, and in what context these logs were created, or what is important, or what format was there. These are all the fields in the site, and you can see, yeah, how many counts are there, and so these are all the things in logs you can do with Splunk. So this was majorly about Splunk and logging. If you want to try it out, you can go to your Windows logs and you can try it out as well. It is on free trial. So um, that was majorly it about logging and observability. But this is not the end. This is the first part of our observability series. If you liked it, we will be hosting another session next Tuesday for metrics and traces. So these are, and we'll go forward and we'll talk about visualization and many other tools. Like in this video, we talked about Splunk because that is the widely used tool for logging. Then we'll talk about other tools as well, for example, Grafana, Prometheus, etc. Whatever the major highlights or widely used tools for the corresponding aspects. And if you like the video, you can like and subscribe our channel. Also, you can follow us on LinkedIn and you can connect with us on our community. If you have any questions, you can drop it into the comments, or you can also connect with me on LinkedIn. So thank you for joining, and I'll see you next Tuesday.